Hello everyone. In this video, we'll discuss all about DC load line. So when we are talking about transistor, we'll come across with a point called as DC load line. So what is this DC load line and how to calculate the DC load line for a transistor will be discussed in this session. So first of all, what is meant by DC load line? So when we are analyzing a transistor characteristics, every time when you want to know the output voltage, output current with respect to the input voltage and the input current, when we do it in a traditional way with using some meters or so, or with any help of any CRO, it will be a tedious process. So in order to simplify the method of calculating the output voltages and currents of a transistor and to analyze the transistor characteristics, we generally use a method of knowing the characteristics of a transistor with the help of a DC load line. So simply what we can say about the DC load line is it is a line which shows the relationship between current and voltage of a circuit when any load is applied to that particular circuit. So why it is called as a DC load line? Why not AC load line? Because DC load line is called as DC load line because it is a load line, or this is a line which is drawn on the output characteristics graph when the DC parameters are prevailing or when no signal is applied. That is why it is called as DC load line. I repeat, it is called as DC load line because it is a line which is drawn when a load is applied to the transistor circuit to the output characteristics, and that too when the DC conditions are prevailing or when no signal is applied. That is why it is called as DC load line. So when talking about DC load line analysis is an analysis which is the easiest and the frequently used method to know the circuit parameters. So that is why almost all the transistor analysis methods will be utilizing DC load line analysis only. So the DC load line method which is used in the analysis of transistor application. So when you want to research or when you want to know whether a particular transistor is suitable to your particular circuit, you want to then you have to select a particular transistor, and for the selection of that particular transistor you need to check its characteristics. In such a case, this DC load line analysis will be very useful. So the next point is how to draw the DC load line. Here two points are to be noted before we draw a DC load line. First is it is a line which is used to know the transistor characteristics. First point. Second point is it is a line which is drawn when no signal is applied. Okay, so to know the circuit parameters is the first point, and when you are drawing this, the signal will not be applied. That is the point. So the next point regarding DC load line is this load line is drawn for the output characteristics of a transistor. Okay, so all these 3 points are to be noted when you are interested in drawing a DC load line. And next is it is a line which is drawn on the output characteristics curve. That is, in general, we draw the output characteristics of any transistor. In general, we take the output current, that is VCE on the x-axis and IC on the y-axis. In general, VCE is the collector emitter voltage, will be in volts taken on the x-axis, and IC which will be either in milliamperes or microamperes, will be taken on the y-axis. So it is called as DC load line because DC condition exists in the circuit, that is no signal is applied to its input. This we already discussed. Okay. So when we observe a circuit, when you observe this circuit is nothing but a common emitter circuit, which we have already discussed previously in the previous video. So here when you see there is no signal applied, this is a CE configuration, and when you apply some input signal later, you can obtain an output. So this is a normal CE configuration circuit. So when you consider this circuit, you obtain some output characteristics. So that I have taken here. So when you see this, this is a output characteristic graph, that is IC on, that is collector current on the y-axis, collector emitter voltage on the x-axis. So this is a simple CE configuration graph, right? After drawing, after getting the characteristics, so some line, here you can see a line which is touching the collector current and the collector emitter voltage. This particular line is called as DC load line. Okay, so this line is the line which is drawn between collector current and collector emitter voltage. We call it as DC load line. Now we'll know the procedure of drawing this collector current. So for this we need to use a circuit here, that is this circuit. So when you look into the circuit, when you observe this circuit, if you apply Kirchhoff's voltage law for the output circuit, so you can simply write the output expression for this loop. The output expression for this loop can be written as, the output expression for this output loop can be written as VCE will be equal to VCC minus, here we will be observing an output called as ICRC. So simply the Kirchhoff's voltage law is applied to the output circuit and it can be written as VCE is equal to VCC minus ICRC. Okay, so that you can observe here. So VCE collector emitter voltage will be equal to VCC minus IC into RC. This is the expression we need. So when you observe this expression, here our required parameters are IC and VCE. Both are existing in the same expression. So from this expression, we'll try to extract the values which can give the points A and B here. Okay, in order to get these points, what we'll do is, so first if we consider IC collector current, if we consider IC to be 0, then you can simply write that VCE is equal to VCC. Okay, once again I repeat, in the first case, if you make the collector current IC to be equal to 0, then we'll get to know the maximum value of VCE. Okay, so when you make IC is equal to 0, VCE, this will become 0, then VCE will be equal to VCC. So that is why here you observe I have taken a point on VCE. On VCE, I have obtained a point called as VCC. So clearly you can see here, when you make IC to be equal to 0, VCE will be equal to VCE will be equal to VCC. So here you take a point called as B. Mark a point called as B and write there as VCC. If needed, VCC comma 0 can be written for clear understanding. Next case will make VCE to be equal to 0. Then what will happen? We'll see. When VCE is equal to 0, that is when you are applying 0 collector emitter voltage, then we'll get to know the maximum value of IC. For that to happen, so by simplifying this expression, from this you can get IC is equal to VCC by RC. That is, if you want to know the maximum value of IC, you simply make VCE to be equal to 0. So when you make VCE is equal to 0, if you make VCE 0, then IC will be equal to VCC by RC. Okay, so from this you can get a point called as, when you make VCE to be is equal to 0, you get a point on y-axis, that is nothing but VCC by RC. Okay, so what will happen is that now you got 2 points. Initially when you made IC is equal to 0, you got a point called as VCC comma 0 on the x-axis, and when you made VCE is equal to 0, you got a point called as IC is equal to VCC by RC here. So when what we do is we make the point VCC by RC as A and VCC comma 0 as B. These 2 points, when we join together, we come across, or we get a line which is in a straight way. That is, we get a straight line. Okay, so this line which is joining the coordinates VCC by RC and VCC is called as DC load line. So, or simply I can say the line that is joining the points A and B on IC and VCE graph, or simply output characteristics graph, is nothing but the DC load line. Okay, so why you need to consider to be as the straight line is, so when we consider this output expression which we previously got in the when we applied Kirchhoff's voltage law to the output circuit, VCE is equal to VCC minus RC. So when we extract the value of IC, so the value of IC will be equal to minus 1 by RC. IC value will be equal to minus 1 by RC into VCE plus VCC by RC. So when we observe this expression, which we derived from this expression, this is very much similar to an expression what we generally do in mathematics, that is straight line expression, what we simply write as y is equal to mx plus c. So this expression, IC current expression, is similar to a straight line expression. That is why when you join the points A and B, we join it as a straight line. Okay, so this line which is a joining line between A and B is considered to be the DC load line. Okay, so the DC load line will help you in understanding the transistor parameters. In other way, what I can say is, this DC load line help you in adjusting the operating point, which is very essential when you operate a transistor. So when you know the operating point of a transistor, then faithful amplification can be achieved. So in the previous video, I was talking about faithful amplification. So in order to get faithful amplification, stable operating point should be chosen. If you want to choose an operating point, initially you have to know the DC load line. So after tracing the DC load line only, you can mark the operating point on the transistor characteristics. So that is why this DC load line analysis is very much important when you want to operate a transistor, and also when you want to obtain a faithful amplification. DC load line will help you in choosing the best operating point. So that is why when we talk about transistor, DC load line analysis is considered to be very important in knowing the transistor characteristics. So why this is very much important is, when compared with the traditional methods of calculating the collector current IC and collector emitter voltage, this is the most simplest way of calculating the collector current, that is output current, and collector emitter voltage, that is output voltage. So for any value of the output characteristics that you get for any point, you can know. If you just know the current, you can easily calculate the voltage, or else if you know the voltage, you can calculate the current. Anyway, any other way you can do the calculation simply by drawing the DC load line. So that is why DC load line is considered to be a very important analysis when we talk about transistor. So with this I conclude the session. Thank you.